Okay, so we're up to chapter 10 of Introduction to Networks. So which of course is the application layer. So the last one in that series. And so then, yeah, as I said, there's chapter 11, which is an overview plus adding security. Okay, so we're going to look at some application layer protocols. And so we'll explain how they support end-to-end user applications. Of course, we're talking about the TCP application layer. So of course that includes ISO, so OSI layer model for application, session, and presentation layer. And so then we're going to talk about some well-known ones like web, email, DNS, DHCP, and FTP. So application layer protocols. And so, of course, if you're talking about the OSI model, it's only the top third of the TCP one, but basically we're going to talk about the TCP model because that's the one that's in use. So it's closest to the end user, used to exchange data between programs running on the source and destination hosts. And so be whatever that data may be. So of course the presentation layer, it does the formatting of data at the source so that the receiving device can understand it. It can also do with compression and encryption. So as we said, you know, we've got ASCII or Unicode, you've got MPEG, GIF, JPEG, PNG, all kinds of things like that. And so in the session layer, creates and maintains dialogues between source and destination applications. Okay, so some common application layer protocols. So there's of course DNS, how we find the IP address for a given name. There's bootp, which is basically the old version of DHCP. There's DHCP, of course, which is Dynamic Host Configuration Protocol, and so that's of course how you automatically assign IP addresses to a host. SMTP is how you send emails, and then POP and IMAP are alternate ways that you can receive emails, basically. And then there's File Transfer Protocol, which is a reliable way of sending data or files across the internet. There's Trivial File Transfer Protocol, which is a less reliable way of moving files. And then, of course, there's web servers, be they insecure on port 80 or plain text, basically, or encrypted, as in port 443. So, most of these connections we're talking about are client-server processes, and so you need to have this matched set. So if you've got a web browser on your host, you need to connect to a web server on the server, and so that's how you interact with the data that they want to move. And so those client and server processes are considered to be application layer. So application layer protocols describe the format of the requests and responses between clients and services. An example of a client-server network is using an ISP's email service to send and receive and store email. So with peer-to-peer networks, now this is sort of the traditional way of talking about peer-to-peer, and that's basically where you don't have a specific server, and so each client might be a bit of a server in some things and it might be a client in other things. And so in this case we've got peer 2 that's got a printer that it can share, so it's being a print server, but peer 1 has files that it's sharing, and so it's being a server for the files, but it's being a client for the printer, and peer 2 is being a server for the printer and it's being a client for the files, and so they sort of mix and match. Of course, there are peer-to-peer applications, and so you can have internet chat, or of course there are other options as well. And so probably BitTorrent is the best known peer-to-peer application, and it's not actually illegal to use BitTorrent. It's just the data you're moving across it may well be infringing copyright. But if you've ever downloaded Linux, often there is the option to download it with BitTorrent, and it is often pretty quick. So it certainly has its upsides. All right, some well-known application layer protocols and services. So Hypertext Transfer Protocol and Hypertext Markup Language are basically a set So HTML, of course, is how you create a web page, and of course HTTP is how you move that web page. And so of course, so they are very much a match set, and they've both got hypertext in their name, so that sort of gives the hint away. So how do you get to a web page? Well, you normally need to type in a URL or unique resource locator, and so you type that into the browser, and then the web browser creates a connection to that web server and transfers the file that you requested, basically. Now, so it's a request response protocol, as we suggested in the previous one. And so there were three common message types: is get, post, and put. And so get, of course, is what a client requests. Post uploads data to the web, and put uploads resources or content to the web server. And so there's also HTTPS, which of course is the same, except it uses encryption and authenticates the source machine. Email. So there's three major protocols that are used for email. And so basically, if you send an email with an email client, your email client will talk to your email server and send that message using SMT, Simple Mail Transfer Protocol. Then, of course, if that destination email is from a different domain, so if you're Flinders and you're sending it to someone in Cisco, they will be in two different mail domains, and so then the mail server, your mail server, will then talk to the destination mail server and try and find out its details. So you'll do a DNS lookup and look for an MX record or mail exchanger, and then it will actually send it to the destination mail server, and that is also using SMTP. So then when it gets to the destination mail server, it's stored in your mailbox basically, and then from there you use either POP or IMAP to retrieve the email. Now, I think there's actually more on the next slide. And so, as I said, SMTP is used to send an email, and it's also and so it also is used between your server and their server. But to read your emails, the older, more traditional way to do it was using POP, or Post Office Protocol. Now, what POP does is it downloads the emails from the server and deletes them on the server. That's what it typically does. Some applications allow you to stop it from doing the delete bit. So basically, the reason for that was back years ago, you used to only get 2 meg or maybe 10 meg of storage on their email server. And so if you left all emails on the server, eventually that would fill up, and it didn't take all that long. And so you would actually stop receiving emails after that. So you had to download them. Of course, you're the only one that had a copy of that, and so you were responsible for keeping them, basically. So that's old school, while IMAP is the newer one. And so, again, it's just the delivery to the recipient that IMAP does. And so, basically, it takes a copy of those messages, and you can have it on your local client if you want, but it actually leaves them on the server, so you can actually access them from more than one computer. And so often, especially these days, web mail and things like that are options, and so they're all there, all visible for you. So another application layer protocol, of course, is DNS. So domain name service converts basically the human-friendly name into a computer-friendly IP address. And so DNS protocol defines an automated service that matches resource names to the required numeric network address. So the DNS uses the same message format for all client queries and server responses, error messages, and the transfer of resources between servers. And so basically, there is a question part of a segment, there's a resource part of the segment, and there's a authority, and then there's any additional information as well. So when a client makes a query, the server's DNS process first looks at its own records to resolve the name. If unable to resolve it, it contacts other servers to resolve the name. The server temporarily stores the numbered address in the event that the same that same name is requested again. So you can actually on Windows type in ipconfigs display DNS, and that will actually your machine will have a cache of DNS entries that it's made recently. And so once it's done that, it will reuse them until they expire. So basically, DNS is hierarchical. So I'm assuming you've all heard of the root servers. And so the root servers basically know how to get to the first or top level domain servers. And so they're the implied dot at the end of every domain, fully qualified domain name. So they know how to go to .com, .org, and then of course .au, .co, whatever it might be. And so if you wanted to get to flinders.edu.au, the roots, and you were on a completely different domain, from your ISP would then first ask the root servers how do I get to the .au DNS servers, and they'll tell it, and then last the .au, how do I get to the edu.au, and then from that you'll ask the edu.au, how do I get to flinders.edu.au, and so on. And so that's basically the hierarchy. And so you work from the right hand end of the domain name to the left, basically. And of course the last one, if it was www.flinders.edu.au, www was the host name of the host of the web server, basically. But you could have called it Fred or Mary, but typically we call it www. Okay, so with an NS lookup, it's another tool we can use to test DNS. And so it's a utility that allows a user to manually query the name server to resolve a given host. Can also be used to troubleshoot name resolution issues and to verify the current status of the name servers. And so you can type in, NS lookup, and then you can actually then type in a whole series of host names to look up, and so it'll give you answers. Or you can just do NS lookup cisco.com, and it will just do that one. Okay, so DHCP, and so basically it automates giving IP addresses to hosts. Of course, when you host boots, it sends out a DHCP discover message, and so from there, any DHCP servers will reply with a DHCP offer, and then the favored one. Typically, you won't get more than one, but anyway, the client will then send a DHCP request saying, "Can I have this address, please?" And then it'll get an acknowledgement. So there's, as I said, 4 segments that get exchanged in DHCP, and there is version 6 for DHCP as well. So you can certainly do that. So as I said, there's discover, offer, request, acknowledgement, basically. FTP is a strange one, and so it has those 2 ports, 20 and 21. So 21 is the control port and 20 is the data transfer port. And so basically, if you're requesting data, you actually request it from port 21 because that's the control message, but then port 20 will send it to you. And so FTP can actually be a bit of a challenge to get through firewalls because it doesn't act like any other protocol. So sometimes you might actually have to add extra modules that sort of support FTP, otherwise it'll get blocked. Or you can also put FTP in what's called passive mode, and that will sort of be a little gentler. No, I think this is the last product we talked about is SMB or Samba, and so of course SMB is how file sharing and print services work on Microsoft networking, so in Microsoft servers. So clients establish a long-term connection to the servers and can access the resources on the servers if they're a local host. And of course there is an open source version of that called Samba, and it was actually developed originally here in Adelaide by Mr. Tridgell. Clever boy. Okay, so we are pretty much finished with chapter 10. So basically we've looked at where application layers sit in the stack and what they do to support end-to-end applications, and we've looked at some of the best known application layer protocols. So there's the logo, and so that's the end of chapter 10. We just have chapter 11 to go, which I said is an overall scenario, plus we look at also some security issues as well. So I'll see you then.